Okay, so after legalizing all the expansion series, let us take a couple of examples to use which series. Log 1 plus x to the base e, we have already written as x minus x square by 2 plus x cube by 3 minus x 4 by 4 plus, if we put x is equal to 2, x is equal to 1, log 2 to the base e is equal to 1 minus 1 half plus 1 third minus 1 fourth plus 1 fifth. So it is alternate reciprocal. Alternating reciprocal sequence converges to log 2. अजून काय कोणती कोणती find expansion for log 1 plus x upon 1 minus x. What हो गया? Find the expansion for log 1 plus x upon 1 minus x. Hence find log 2020, the basic. Using properties of logarithm, you can write this as log 1 plus x minus log 1 minus x. Log 1 plus x series we know. Now you find out what is log 1 minus x series is. Putting x is equal to opposite of x everywhere and then subtract them, you will get the series. And hence find out log 2020. This is going to be equal to 2 times x plus x cubed by 3 plus x fifth by 5 plus dot dot. Find log 2020, I mean series expansion. Now 1 plus x upon 1 minus x, you can consider 1 plus x upon 1 minus x is equal to 2020. So how much is x? 1 plus x is equal to 2020 minus 2020x. So 2021x is equal to 2019. Therefore, x is equal to 2019 upon 2021. And it is less than 1. We want it to be less than 1 so that we can use our log 1 plus x effectively. No problem with that. So putting this x back into this equation, you बरोबर आहे ना? x पाहिजे आपल्याला तो इथे टाकायचा. So log 2020 is equal to 2 times 2019 upon 2021. plus 2019 upon 2021 cube, 1/3 plus 1/5, 2019 upon 2021 raised to 5 plus. That is how it is. Your calculator will use this formula to find out logarithm.
सर पण मग आपण म्हणजे सरळ सरळ 2019+1 वापरून सगळ्यात वरचा फॉर्म्युला का नाही वापरता आला? कारण हे थोडं किचकट होईल ना.
1 plus x वाला,
हा.
अरे तिथे कंडिशन काढली ना बाबा काल की x कॅनॉट बी ग्रेटर दॅन 1 म्हणून.
हो हो.
किचकट होईल म्हणजे काय, लिगल तर पाहिजे आणि ते चुकणार, ते बरोबर नाही येणार. log 1 plus x is equal to 2019 टाकलं करून बघा कॅल्क्युलेटरवर. Oh, that is good idea. Check on your calculator by using first formula and put a value of x is equal to 2019 and using this formula there will be difference. If alternating reciprocals converge to log 2, question comes in mind, what happens to not alternating reciprocals? What is this sequence? S is equal to 1 plus half plus 1/3 plus 1/4 plus 1/5 plus dot dot dot. What will happen to this? That is a new question. Sangha. And whatever is your answer, you should have proof for that. We wish to find out what this S is. Summation of reciprocals of natural numbers as n tends to infinity. And if we do, show that some other number which is smaller than this, some other number say k, which is smaller than s, itself tends to plus infinity. Then of course s will tend to infinity. So are we able to estimate a smaller number than s which tends to infinity? Yes, we can do that by doing this. We write it as 1 plus half. Now in place of 1/3, if I write 1/4, in place of 1/3 if I write 1/4, then s is greater than this number plus 1/4. For 1/4 I write 1/4. For 1/5 I write 1/8. For 1/6 I write 1/8. For 1/7 I write 1/8. For 1/8 I write 1/8. So this is the change group. This is another group. Plus the next group will be of 8 terms. 1 plus 16. How many terms? 8 terms. And will this continue? Yes. Every time I am making this sum RHS smaller than LHS? Yes. So therefore 1 plus half plus half plus half plus half plus how many times? Infinitely many times. Right? And therefore, if you keep adding half infinitely many times, of course, this is going to be divergent. And this quantity is smaller than the required quantity. And the smaller quantity is divergent. Therefore, S is divergent. Okay, that is what is the proof. Whatever you have written in using series expansion is also okay, doable, not a problem. But you have to take limit there because you cannot write log 0. Log 0 is completely wrong. Log k, as k tends to 0, maybe. That will be the correct statement. Okay, so let me give you another one for your guess. S is equal to, let me make squares. 1 plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square, 5 square plus dot dot. Decide the future of this S now. It is the similar reciprocal sequence but squares in the denominator of all natural numbers. Okay, this is the earlier one was divergent, this one is going to be convergent. Let us try to do it. 1 plus 1 upon 2 into 2 plus 1 upon 3 into 2 plus 1 upon 4 into 4 plus 1 upon 5 into 5 plus that, correct? So 1 upon 2 into 2 can be written, suppose I write 1 plus 1 upon 1 into 2 in place of 2 into 2 plus 1 upon 2 into 3 in place of 3 into 3. So 3 into 3 was 9, denominator was bigger, fraction was smaller. Denominator is smaller, fraction is bigger. So I should write inequality like this. This quantity will be less than what am I writing right now? Plus 1 upon 3 into 4 plus 1 upon 4 into 5 plus dot dot, correct? And now we are good at splitting them. 1 plus 1 upon 1 minus 1 upon 2 plus 1 upon 2 minus 1 upon 3 plus 1 upon 3 minus 1 upon 4 plus 1 upon 4 minus 1 upon 3 plus something. And then we find that these two guys are 0, these two guys are 0, and so on. There will be many like that. So therefore, this will be equal to, of course, the first two will survive. So 2, and there is, I mean, actually, we are supposed to have the last term, which is going to survive with a negative sign, but there is no last term. And the last term is going to be, for all practical purposes, 1 upon n, which is n tending to infinity, 0. So practically, this is going to be less than 2. S is going to be less than 2. Hence, convergent. Okay. So the idea here is, if you want to prove a sum convergent, then you prove that something bigger than that is also convergent. If you want to prove some divergent, then you prove that something less than that also tends to infinity. Okay. If you do it opposite, suppose we want to prove something divergent, and instead of finding out the smaller quantity which is tending to infinity, if we find out the bigger quantity which is tending to infinity, we will not be able to say anything about S, because something bigger than S is tending to infinity does not mean that S tends to infinity. But if something smaller than S is tending to infinity, definitely means S is tending to infinity. Same will be the case, similar will be the case for converging sequences. Okay, so that was just a sidetrack. Now we are done with the series expansions, and now therefore we have to move. Let me stop recording and decide what to do now. Okay, so now what we have seen is, if we want to have series expansion of a function, the constraint is, what is the nth derivative? Is the function differentiable n number of times? That is one part. And second part, how do we find out that derivative, nth derivative? For that matter, all the derivatives in between which are required. So therefore, what we will begin now is the study of finding higher order derivatives, that is successive differentiation one after the other. And we have already started that by finding out nth derivative of sine, cos, e raised to x, etc. But if I have some complicated functions, will I have a method to find out the higher order derivatives? So suppose now I have y is equal to, example 1, y is equal to sine 5x. Find y 100 derivative of sine 5x. खड़ा हो गया. Okay, so hence what is y nth derivative? Hence y n is equal to nth derivative of y. Answer for this is 5 raised to 100 sine 5x. That is the 100th derivative of sine 5x. What will be nth derivative? Nth derivative will be 5 raised to n sine 5x plus n pi by, that will be your nth derivative. Okay, example 2. Y is equal to sine ax plus b, where n be a parameter. How much is y? Now, instead of many times notation, instead of writing it as nth derivative as y raised to n, many times you will find it is written yn is equal to. That also means nth derivative. On text of the question you have to read properly and understand the notation. So find what is nth derivative of sine ax plus b. Correct. Pranam. Aditya correct. Mohit correct. Nayan correct. Vendale correct. Om correct. Atharva Parulekar correct. Chinmay correct. Pote correct. Saranade Kamalapur. Sale correct. All those who are showing, it is the correct answer. Okay. So, I had not stopped recording. Good that I am writing the answer quickly. A raised to n sine ax plus b plus n pi by, example 3. Y is equal to sine cube x. Find nth derivative of y is equal to sine cube x. Sine cube x can be written as 1/4 of 3 sine x minus sine 3x. Yes or no? Therefore, y is equal to 3/4 sine x minus 1/4 sine 3x. Therefore, we should be able to find out the derivatives. I mean, this is individual function, this is individual function, and they will keep behaving individual functions. Doesn't matter whether you are differentiating them or not. So, we know how to go about it. We know how to go about this also. So, maybe final answer is 1/4 out inside bracket, 3 constant out sine x plus n pi by 2, that is what is a derivative of sine x, minus 1/4 is taken out, sine 3x we have done just now, 3 raised to n sine 3x plus n pi by, that is what is your derivative, nth derivative of sine cube x. अरे कळलंय का आता ट्रिग्नोमेट्री काय इम्पॉर्टंट आहे ते. नाउ हियर नोबडी इज गोइंग टू say that this is extremely difficult. I mean, this is easy. This is very easy. Example 4. Y is equal to sine 3x cos 5x. Find the net derivative of sine 3x into cos 5x. So the answer for fourth question is half inside bracket 8 raised to n sine 8x plus n pi by 2 minus 2 raised to n sine 2x plus n pi by 2. Easy. Okay, so now I think you will not have any problem with respect to trigonometric function and finding its derivative. Here it is assumed that you are very good at trigonometry and you remember all identities of trigonometry. If you are struggling with trigonometry, then of course you will struggle with this. Lakshat gya. So if you are good in trigonometry, this is going to be very easy for you. Example 5. Now let us check. Let us do some work for algebra. Y is equal to ax plus b raised to m. Find nth derivative. Find yn. दरवाजे उघडा राहायचा. if m is greater than n, then yn is equal to, बोला, n into n minus 1, n minus 2, पुढे कितीपर्यंत, बरोबर,
m into m minus 1 into
हाँ.
dot dot dot.
अरे हाँ, पावर m है ना, m so is equal into what, m minus n plus 1, that is the corresponding coefficient which is coming every time a will come, it will be present n times, and then you will have a x plus b present m minus n times. That is what is your nth derivative of ax plus b, and if n is smaller than m. Take next example.
Sir,
Yes,
is m given to be an integer?
yes, yes. Oh, example 6. Y is equal to 1 upon ax plus b. Find y. So yn is equal to minus 1 raised to n factorial a raised to n divided by ax plus b raised to n plus, good, 7. Y is equal to 1 upon x square minus 7x plus 10. And yn. Convert given problem into the problem whose solution is known to us. So if we factorize the denominator, we get 1 upon x minus 5 into x minus 2. Using partial fractions, you can split them. 1 upon 3 times 1 upon x minus 5 minus 1 upon x minus 2. So that makes it two problems of the kind example number 6. Therefore, yn is equal to 1 upon 3 times. A is 1, B is minus 5. So answer is minus 1 raised to n. N factorial A is 1. So that is gone. Divided by x minus 5 raised to n plus 1 minus 1 raised to n factorial divided by x minus 2 raised to n plus, that is what is your nth derivative. Very good. So now if some initial trigonometric simplification you do and find out initial algebraic simplification, this is initial algebraic simplification you do and use the previous standard nth derivative formula to find the next. Okay. Now, what we are going to enter into is, suppose, example 8. Suppose I have y, that let me y 0, which is 0th derivative, that means it is y. Okay, I could have called this also 0. Suppose y is a function of x, which is given to be equal to u, which is yet a function of x, into v, which is function of x, and they are original functions of x. Put a 0. They are not derivatives or something like that. Whatever function is given to you, 0. So say for example, x raised to 3 sine 5 theta, y is equal to. Okay. So I will call y0 is equal to u0 into v0, where u0 is equal to x cubed, v0 is equal to sine 5x, something like that. Okay, so suppose instead of taking a specific function, if we take u0 as a function of x and v0 as a function of x, then what is y1? Y1 is, we have to apply product rule for derivatives. u0 v1 plus v0 u1, correct? Now if we want to find out second derivative, what will be the second derivative? Again product rule, u0 v2 plus u1 v1 plus v0 u2 plus v1 u1 makes it u0 v2 plus 2 times u1 v1 plus u2 v0. Find yn. Nth derivative. Second derivative, the coefficients are 1, 2, 1. Third derivative, the coefficients will be 1, 3, 3, 1. And it follows pattern like binomial theorem. And that is why it is extremely important formula. Answer is sigma r goes from 0 to n choose r into u n minus rth derivative v rth derivative. Add all of them, that will be your nth derivative. This is formula by Leibniz. Leibniz theorem for finding out nth derivative of product of two functions. Question. Y is equal to e raised to ax sine bx plus c. Find y.